Good day everyone. We are pleased to present our final requirement for CAD 221L, the HVAC project for the Industrial Engineering Faculty Room. This project represents the culmination of our modeling efforts this semester. Our team is composed of all the students of Section 1D. We would like to also acknowledge the guidance of our instructor, Engineer Jabez A. Isoli, whose mentorship was vital in the completion of this design. Our objective today is not just to show you a 3D model, but to walk you through a fully realized facility design, from the structural layout to the furniture, and most importantly, the specialized HVAC system we have engineered to solve the specific ventilation challenges of this room.
Let's begin with the facility itself. We are working with a modified structure for the IE department. The dimensions are substantial. The room measures 8.09 meters in length and 3.73 meters in width. However, the most critical dimension for our HVAC calculations is the height. The ceiling stands at 3.40 meters, which creates a significant challenge. When you calculate the total volume, we are dealing with over 100 cubic meters of air. In our Solidworks model, you will notice that we created a hollow space above the ceiling. This was a deliberate structural modification designed to conceal the ducting, ensuring a clean interior look. We also modeled a canopy at the back of the facility, which serves as the designated housing for the outdoor air conditioning unit.
Moving into the interior, we focused on modeling furniture that serves the functional needs of the faculty. First, look at the storage solutions. We modeled two distinct cabinet types. The main cabinet is a large wooden unit designed for comprehensive storage, tools, books, appliances, and department displays. Beside it, near the door, we placed a specialized corner cabinet. This smaller unit maximizes the usage of corner space, which is often dead space in a room, providing quick access to frequently used tools. For the workstations, we positioned the instructor's tables at the back portion of the room. These aren't just generic blocks. We modeled them with a darker wood texture to contrast with the lighter walls. We also detailed the specific compartments required for instructors, ensuring there is space for personal items and educational supplies.
Comfort is key for a faculty room. We spent time detailing the office chairs, of which there are two in the room. The design intent here was modern yet simple. If you look closely at the model, you can see the different materials we applied. The supports are modeled as metal for stability, while the body uses plastic components. For the seat itself, we applied a canvas textured fabric appearance with visible cushioning underneath. This level of detail in the texture mapping helps visualize the actual comfort level of the furniture.
Small details define the usability of a room. Near the entrance, we mounted a whiteboard with a plastic surface and a metallic frame. It's positioned specifically for high visibility, allowing faculty to post schedules and reminders where they can be seen immediately upon entry. For lighting, we installed two fluorescent fixtures. In SolidWorks, we modeled the aluminum casing and the glass cover separately. The glass cover is crucial. It's not just an aesthetic choice, it's modeled to demonstrate how light is diffused through the room, ensuring there are no dark spots in a space with such a high ceiling.
Let's look at the ingress and egress. The door is a wooden assembly featuring a central glass pane. This transparency is functional, allowing students or employees to check availability without disrupting the room. We also paid attention to the hardware. We modeled 4 stainless steel hinges on the side of the door frame to support its weight. At the rear of the room, we have a large window. This is framed in aluminum and features a 0.6 cm thick glass pane. This specific thickness was chosen for durability. Placing this window at the back allows natural light to flood the workspace, reducing the reliance on artificial lighting during the day.
Now, we arrive at the core of our project, the ventilation equipment. We selected a split-type HVAC system. Let's break down the components. The outdoor unit. Placed on the rear canopy, this contains the compressor and the condenser. It isolates the noise and heat generation outside the faculty workspace. The ducting. We modeled this using aluminum. It serves as the bridge connecting the inverter to the diffusers. The diffusers. These are the exit points for the cool air, also modeled in aluminum and attached directly to the ventilation duct.
You may ask, why do you go through the trouble of a ducted system for a single room? Why not a simple wall-mounted split type? The answer lies on the physics of the room. As I mentioned earlier, we have a huge floor area and an exceptionally high ceiling with a 3.4 meters high. A standard wall-mounted unit would only effectively chill the air immediately in front of it. It would struggle to mix the air in a volume of 100 cubic meters. By using a ducted system, we gain a higher static pressure. This allows us to position the supply diffuser strategically across the ceiling. This guaranteed that whenever you are sitting at the desk, in the back, or standing by the cabinet in front, the temperature is consistent. Furthermore, it's about aesthetics and acoustics. Concealing the fan coils unit above the ceiling removes the visual clutter, creating a professional look. Significantly reduce indoor noise since the mechanical parts aren't in the occupied space.
In conclusion, our SolidWorks project is more than just a collection of parts. It is a cohesive system designed for human comfort. We successfully integrate a structural constraint with ergonomic furniture and a robust high-capacity HVAC system. The result is a faculty room that is functional, comfortable, and aesthetically professional. We believe this design best serves the needs of the Industrial Engineering Department. Thank you for your time and attention.